Okay, this is a few more composite shapes. Most of these ones include circles or parts of circles, so I'll do a few of these and get you started as well. So the first one in number 1, and again, I don't really care how you set these out, so don't get too stressy about the presentation. But what you can see here in number 1 is that we've got a square here. I can tell it's a square because I've got the markers here telling me all the sides are the same length. They've called that A2. It doesn't really matter where I present this. I'll just change my pen colour. They've put A2 down here, and they've just said that that's my length squared, so it's one side times the other. Have they told me the length measurement? They did. I've just drawn all over it. So the length was 9. So in this case, it's going to be a 9 squared. So 9 nines are 81. So we know that that one would be 81 centimetres squared. Now, to get the little bit that looks like a quarter of a circle, we're going to use the formula for the area of a whole circle, and then basically divide it by 4 or times it by a quarter is the same thing. So the area of a circle is pi times your radius squared, and you can see that they've got that little formula there, pi times the radius squared. And then they've times that by a quarter because we've got a quarter of a circle. So a quarter times pi times my radius, which is that measurement of 9 along here, squared. So if I pop that into my calculator, bear with me for a second. And you can put the quarter in just looking like a fraction as it is, or you can put it in as a 0.25 into your calculator. It doesn't matter which way you go. Your pi button, if you're using one of the scientific calculators, you need to hit shift, and then I think it's the 10 to the power of x. I haven't got one in front of me, but you'll see it at the bottom, you'll see it in orange, written in orange on the top with the pi button, and it's shifting that one to hit it. If you can't get it, then pi is roughly 3.14. So I'll finish putting mine into my calculator there, and that gives me 63.6. That's to 1 decimal place. So, oopsie, sorry, my bad. So 63.6 centimetres squared. You can probably hear my dog snuffling in the background. I apologise for that. So then we just need to add the two areas together. So my A1 was my 63.6. My second area was that 81 that we calculated initially. And so together we would have had 144.6 centimetres squared. Okay, if we look at the next shape, it's the same sort of deal, except now what we've got is half of a circle. So again, we'd use the formula for the whole circle, which is pi times r squared. And then we're going to halve that answer. So either timesing by half or divide your answer by 2. Both will do the same thing for you. And then we need to add the rectangle to that, which is just length times width. So let's have a go over here. They've prompted you with the half times pi times r squared. Pi times r squared is your full circle. We're timesing it by half here because we've only got half a circle. Now, this little measurement here means that the two sides are the same, and they've told me that they're both 14. So that would be, now one little trick here, that would be the length of the whole diameter of the circle, but our formula for circles only use the radius. And the radius, of course, is half of that. So the radius would go from the halfway mark across. So I would need to halve that 14. So 14 divided by 2 would give me a 7. So the radius number that I need to use will be a 7. So over here, I'm going to have a half times pi times 7 squared. Now, don't forget, if you can't find the pi button, then pi is approximately equal to 3.14, but otherwise it's shift and that button with the little 10 thing on it. Now, that's your half a circle. Plus, we've also got the rectangle, and that's just your length times your width. It doesn't matter which order and which way around you do that. So 9 times my 14 for the second one. And I can calculate each of those separately, or I can just do it as one calculation. They've shown it as the two separate calculations. It really doesn't matter which way around you go. So 0.5 times pi times 7 squared. That part of the calculation would have given you 76.969 and a bit. Plus 9 times 14. 9 times 14 will give you 126. And when I add them together, oopsie, sorry, my bad. When I add them together, I'll get 202 So my final answer here, 202.969, yada, yada, yada. Did they tell us how many decimals they wanted? They wanted all of these answers to 1 decimal place. So as a final step, if I'm going to stop at 1 decimal place, so I'm stopping here, I'd need to check the next number. If that's 5 or more, then I have to bump my number up. In this case, because it's a 9, what I'm actually going to do is I'll have to bump up the next number, so I'm going to wind up with 203. And just to acknowledge that I have done the decimal thing, I'd put a 0.0 there to show that I have taken it to that 1 decimal. Okay, the next one we've once again got half of a circle, and they've tried to do the same trick. What they've given you there is the diameter of the circle, so the full distance across the circle instead of the radius. So what we need to use is the radius, which of course is going to be half of that length, so your radius will be 10. But you'll need that full measurement of the 20 when you come to do the triangle. So they've done the circle first over here, or they've done it second actually, it doesn't matter which order. So, that's the triangle, half base times height. So half my base in my triangle is 11, so times 11, times my height of that triangle, which was my 20. That's going to give me that triangle, so half times 11 times 20 will give me 110, and that was for the triangle actually. And for the semicircle, I'll put a little thing there, then that would be pi r squared times half, because we've only got half of the shape. So a half times pi times my radius, which was 10 squared. So again, don't forget, pi r squared would be your full circle. We've only got half of it, so we're timesing it by a half. Alternatively, I could have just done the pi r squared and then divide by 2. It means the same as timesing by a half, so it doesn't matter which way around you go. So I'll just process that. So pi times 10 squared, which is 100, and halving my answer would give me an answer here of 157.0796, yada, yada, yada. These numbers go on. We won't need all of them because we're only going to go to 1 decimal place. So if I then add those two numbers together, so I've got my 110, so my total 110 plus my 157, with all my decimals so far, is going to give me a total answer of 267.0796 and so on. Now they wanted us to take our answer to 1 decimal place. So if I'm going to stop at my first decimal, it's the next decimal that you need to check, and that determines whether the 0 stays as it is or whether I have to bump it up. If your next number, in this case it's 7, is 5 or more, then you need to bump it up. So ours is more than 5, so I'd have to bump that 0 up by 1. So my final answer would be 267.1. I'll be, quite happy if you get to that answer there without the rounding, but if you want to extend yourself a bit, it's great. You should by now understand that rounding concept. Don't forget your units if they put any on here. In this case they didn't, so we don't need to worry. Right, next one, I'm going to leave you to do this, but I'll talk you through it. So you've got 3 areas here. The first one is half a circle. Again, you're going to need to make sure that you notice that they've given you the full diameter, and what you need is half of that. So you're going to halve your 38. So half of 38 would give you 19. So the radius number that you're going to use would be 19. So you'll go pi r squared, so pi times 19 squared. That would give you a full circle, so you divide that answer by 2. Then you're going to do the rectangle in the middle, and it is a rectangle because they've told, and I'll change colours. So base times width, so 50 times the full 38 there to give you that rectangle. And then you've got a triangle, which is a half base times height. And again, it doesn't matter, which way around you label these things, but your height must come off a 90. So as long as you're using those two measurements, so a half times your 17. And this measurement here is basically the same as that 38 there. So you'll use that and process that through. And then just add up all your shapes together. Here we've got the same sort of concept. So we're going to have the area of our rectangle, base times height, or base times length. It doesn't matter which way around you write that, but basically you'll have your 4.7 times your 7.9 to get your rectangle. And then you're going to take away that quarter of a circle. So take away 1/4 times the full circle would be pi times your radius, which they've told us is 2.9 squared. So you put all that into your calculator and you get the answer. The last one, you've basically got 2 semicircles. So you're going to get the big semicircle, okay? And this one would be pi times the radius of that one is, now I'm assuming that they're actually not half. So they've been a little bit tricky here. We actually they haven't given you the radius. So the radius is going to be half of this full length across here. So first we're going to add the 5.7 and the 6.5. So we're going to go 5.7 plus 6.5. Hopefully you can read my writing there. So 5.7 plus my 6.5 is going to give me 12.2. That is the full distance across there. But my radius for that grey half circle is going to be half of that. So if I divided that by 2, it's 6.1. So I'm going to draw that onto here. So the radius for this full circle would be my 6.1. And I'll just show that working there. So basically I had my 12.2 divided by 2. I've halved it. That's where my 6.1's come from. So pi times my radius, which was 6.1 squared, would be a full circle. I've only got half of that circle, so I can times the whole thing by half. Alternatively, it would be the same if I just had to go and divide by 2. So please yourself which way you prefer to see it. Oopsies. But that would give you the area of the larger semicircle. And then you're going to take away the area of the smaller semicircle. Now for that one, they've given you again the diameter, which is 6.5. And you don't want the diameter, you want the radius. So you've got to halve that, so dividing by 2. And that would give you a radius inside here. I'll go that way so you can see which is which, of 3.25. So then I'm going to subtract, and I'll change colours here. And it's half a circle again. So a half times pi times my radius, which was 3.25 squared. And you just pop that into your calculator and away you go. Now your last one, it looks slightly complicated, but they've just tried to trick you. So basically what's going on here is you're going to get a rectangle. So you're going to have your 14 times 12. Oopsies. 14 times 12 to get your rectangle on the outside. And then you're going to take away basically a whole circle, because you've got 2 half circles. You've got a half circle here and you've got a half circle there. So together the 2 halves will make a whole. You need to make sure you realise that they've given you the diameter again, and what you need is just the radius. So half of 12 is 6. And so you're going to be doing that top number, and then you're going to take away, sorry, it's not a half, it's a whole circle. So take away pi times your radius, which is 6 squared. So pi r squared is that circle. And that will give you that final answer there. So I'll process that for you. So 14 times 12, take away pi times 6 squared, would give me a final answer of 54.9, whatever my units are. They haven't told us what units, so we don't need to put any. But it would be a squared unit. So whatever my answer is, because it's an area, would be unit squared. Okay. What's the area? Just had a sudden thought. I hope it wasn't perimeter we'd asked you to do. Okay. Last one, same deal. You've got a semicircle, and then you're going to subtract from that the 2 triangular areas. Now, these have been pretty nasty. I should have had a better look at this before I signed it for you, because I didn't really intend to freak you out. But this is good practice for us. So what they've done here, though, is they haven't given you the diameter or the radius across the bottom of that semicircle. And to calculate it, you actually need to use Pythagoras. So I'm hoping you're going to remember Pythagoras, but I'm going to recover that with you now. So I'll change colours here to red. So when we want to do a triangle, and in this case they haven't given us the hypotenuse measurement, hopefully you remember using Pythagoras, that hypotenuse, so I'll call it x, shall I? that x would be equal to the square root of the other two short sides squared. So in this case, the square root of 12 squared plus 5 squared. And that's coming from Pythagoras, which tells me that a squared plus b squared would equal to c squared. We never want a squared number. We want just the c, which is the hypotenuse effectively. So to undo the squaring, that's where the square root comes from. So that's all we've done down here. So if I put that into my calculator, be careful. If your calculator doesn't have a button with a square root that looks like it's going all the way over the top of your numbers, then you'll need to make sure you use a bracket. Otherwise, you'll get a BIMDAS error, and it will just square root the 12 squared, and it won't square root the rest of that. So use a bracket if you can't see the square root sign going all the way over. So I'll just pop that into my calculator, and that would give you a side equal 13. So I can see that this would be 13. These symbols are all the same here, so I know that this one's also 13. That means that my overall diameter across this whole shape would have been 13 plus another 13 plus that 3 that we've got in the centre here. So what have we got? 26, 7, 8, 9. So altogether we've got 29 across the bottom. For a circle, of course, I want half of that. I want the radius. So a half of 29 is going to give me 14.5. Now I'm making mine look like quite the chook's breakfast as I'm trying to explain it, but hopefully I'll draw it in the centre there. So my half number will be my 14.5. So when I come to do my semicircle, pi r squared would be my full circle. So pi times that 14.5 squared would be my full circle. I've only got half of that, so I can times this by half, as I say, or I could have gone divide by 2 and left that bit out. I'll just do one or the other. So there we go. That's my semicircle. And then find that one, and then you'll take away the areas of those two triangles. So the area of each triangle would be a half times the base times the height. As we keep saying, the base and the height, doesn't matter which one we call the base, but it's got to be out of those two, the 5 and the 12, because the height has to come off that 90 degree. So the 13 won't be in that calculation. I'm going to call my base the 12, and I'm going to call my height the 5. I could have reversed those. It wouldn't make any difference. And then away we go. And of course, you've got 2 of those. So once you find the area of that triangle, you're going to subtract it twice. So I'll do that one with you. So first of all, the semicircle at the top. So the semicircle at the top would have given you 330.3 if I'm going to go to 1 decimal place. And for the circles, half times 12 times 5. They're at 30 each. Now I've got 2 of those. So my final area would have been my 330.3, take away 1 triangle, take away my second triangle, and there we go. So what have we got here? So that's going to give me 270.3. And there's no units again, so that's all we need to do. So there we go. I hope that was useful. Don't forget to have a go at the practice test as well.